Good morning, everyone. So I realized that district packet kind of starts pretty far into this topic, so I want to do a little introduction with you that's kind of a little further back than the previous video started. But before we do that, Isla wants to say hi, and she's being a creep. Can you just put your head up and say hi, and then we'll move on? Oh, there she is. Okay, that was fun. Okay. All right, so when we talk about similarity, we're talking about something called proportion. And I know for a fact that we did proportions in algebra. You may not remember all the details of it. I put a video up about solving ratios and proportions. So if you don't remember proportions, please watch that. It's the thing where you do the cross multiply. I think some people called it the butterfly when we solved them. It's basically just two fractions that are equal to each other. And that's the thing that we're going to need for this whole unit on similarity. So similarity just means that two shapes or more shapes are proportional. In other words, they're scaled versions of each other. So all of these triangles here on this page are proportional. So you'll notice here, this one that's shaded, he's kind of like the original. And then if you follow out this way, it's the same triangle, it's just getting bigger. And if you follow back this way, it's the same triangle, it's just getting smaller. Okay. Here, this one in the middle, the 100% one, is the original. This one's scaled up a little bigger. This one's scaled down. It's a little smaller. These are proportional. In geometry, we call them similar. We use the word similar to refer to shapes that are proportional as opposed to like numbers. Okay. This is something called a fractal. That is a really cool concept in math where you take a shape and you keep repeating that shape and a scaled down version. So you'll notice we started with a big triangle here, and then if this is an equilateral triangle, they put a smaller equilateral triangle inside of it, and that created more triangles. And then they put smaller versions of the same triangle inside that triangle. And if you look really closely, they keep making teenier and tinier triangles. But the reason I'm showing you this, other than the fact that it's cool, is that every single triangle that you see here is similar to every other triangle that you see here.
Pootie tried to eat Chloe.
Oh, that's unfortunate. Keep Pootie out of your room. Cat tried to eat the fish. Okay, so again, like I said, in geometry, we refer to similarity as same shape, but not necessarily the same size. So if you look at all these beautiful color-coded pictures that I made, all of these circles are similar. Fun fact, all circles are similar because they're circles, so they are by default the same size and therefore also the same shape. Squares, all similar. All squares are squares, so they're all the same shape, but they could be different sizes. Okay. Now, when it comes to triangles, which is really going to be our focus in this unit, they have to be the exact same triangle. So for example, this one and this one are similar, and this one is too, because it's really just a flipped over version of this guy. But this one isn't. You see how this one is a different shape? That's a no-go. Let's see. Like these ovals, they're all the same shape. They're just scaled versions of each other. These two pink ovals, same shape, just scaled versions of each other. These two pink ones, same shape, scaled versions of each other. That's similar. Okay. So it's pretty easy to recognize similar shapes visually. What we want to do, though, is look at it mathematically and figure out how we can A, figure out if they are similar, and B, like find missing values is what we want to do. So this is the notes that we would have taken in class, and we're not going to do them all because you don't need them all. But the question is, what's a ratio? Because the first thing you need to do to be able to write a proportion is write a ratio. So it's literally a comparison of two quantities. So let's see if I can write in here. It's a comparison of two quantities. So there's a couple ways to represent a ratio. Okay, we are almost assuredly going to do them as fractions. So I am sure that you have done these 100 million times. Let's go down here and use 40 trumpets and 24 violins. Okay, so I could write, if I want to do the ratio of trumpets to violins, that's actually one way to write it, to just write the 2 in there. More mathematically speaking, we could write like 40 and then we put a colon and a 24. So we say the ratio of trumpets to violins is 40 to 24. You can also write it, and this is the way we're going to write it, as a fraction, 40 to 24. This is the one we're going to use because that's the one that's going to be able to be put into an equation. Okay. So if I wanted to write the ratio of flutes to clarinets, there's 51 flutes, there's 39 clarinets. I'm just going to write 51 to 39. Okay. Trombones to trumpets, there's 16 trombones, there's 40 trumpets. So 16 to 40. Notice that the one that comes first is on top, the one that comes second is on the bottom. Order matters here. Okay. Well, that was fun. Okay, so a proportion is literally two ratios that are set equal to each other. So it's an equation. So now I'm going to have an equal sign that states two ratios are equal. So literally all of these down here are proportions. So you're going to have a fraction equal to another fraction. Now, I realize that everybody hates fractions. That's fine, because the very first thing that we're going to do is get rid of the fraction. Okay. What we do is, to get rid of the fraction, is we cross multiply. Right? So all we do, if I have a over b is equal to c over d, is we make a crisscross. We take a and multiply it by d. We take c and multiply it by b. And what that's going to do is, in one step, get rid of both fractions, and what you should have on your hands is a one-step equation. So if you look at number 11 here, I'm going to do 4 times 7, that's 28. I'm going to do 2 times x, that's 2x. All I have to do to finish this equation out is divide by 2 on both sides. You literally create yourself a one-step equation. Okay. Over here, oh God help me, I don't know what 19 times 12 is. 12 times 20 is 240 minus 12, 230, 228. I don't know if that's right. 10x. Okay, finish this out. I'm just going to divide by 10 on both sides. I'm almost positive I did that arithmetic wrong, but whatever. So x would be 22.8 if I did my arithmetic right. These down here are a little more complicated. They're going to involve a distribution, but we're not going to look at those ones for right now. We're going to stick with the normal ones. Okay, so what we want to do is use that to figure out values on similar polygons. So we already said similar polygons, same shape, different size. I'm crossing this out. We want to say polygons are similar. Okay, so 2 things to make a polygon similar. Okay, number 1, all angles are congruent. So notice these two triangles down here. One's bigger than the other, but their angles all still match. Look, 50 and 50, 100 and 100, 30 and 30. So if you know that 2 triangles are similar, you know that all their angles match. Beautiful. Okay. The other thing is that the sides are proportional. Okay. In other words, I can make these ratios of sides, and all the ratios are going to be the same. We say that that ratio is called the scale factor.
Mommy,
okay. So, sure, baby. Okay, so let's say this side is 4 and this side is 8. If I have one pair of sides, boom, I know the scale factor. This is times 2. So then if I tell you that this side is 10, you can instantly tell me, well, that side must be 20 then. Because if this side is times 2, then this side better be times 2. Right? If I tell you that this side down here is, I don't know, 18, then it must be a times 2, so this one must be 9. And sometimes you can do it by looking, just like we did there. But sometimes it's not that easy. So what we can do here is, if I give you, can I use a color other than red? Okay. If I give you that this is 4 and this is 8, and then I give you that this is 10, and say, well, what's this side? I can just set up a proportion. So watch what I'm going to do. I'm going to say, okay, well, I know one of them. That's 4 to 8. And this is that guy in the one video I did for you does this. He says you start with the one you know. I have a ratio 4 to 8. On the other side, here's the ratio that I don't know, but I'm still going to write it. 10 to x. Notice I went small over big, small over big. I stayed the same. So now that I've done that, I can do my crisscross applesauce business, and I get 4 times x on one side, and I get 8 times 10, or 80 on the other side. Solve that out, and we get our 20, which is what we said it was in the first place. So if you can recognize the scale factor, just use it, right? But if you can't, like what if the scale factor is a decimal? If you can't recognize it just by looking, then you can always write yourself a proportion like this and do the cross multiply to solve for it. And that's what they're asking you to do in those 2 problems on the homework. They're giving you a setup and you have a missing value. So the problems on the homework are like kind of like this. Now, in this particular problem, they tell you something they don't need to tell you. They tell you that the scale factor is 5 over 3, but I didn't even really need them to tell me that because I could have started with this. I have a pair right here. See this? I have a 10 to 6. So 10 to 6, if you reduce that, is 5 over 3. So they could have just not told us that and forced us to use this pair, right? But they did, so that's fine. So I can either start with 10 over 6 or 5 over 3. It doesn't matter. Those are the same thing. One's just reduced. Okay? So if I want to find x, I need to find, where's my mouse? If I want to find x, I need to find the pair that partners with it. It's over here, right? It's 15. So if 10 to 6 is my initial ratio, then my other one needs to kind of match it. So 15 to x. So 15 to x. I do my cross multiply and I solve it. So I get 10x. Here we go again. I think this is 90. Yeah. Okay. So then x is 9. Okay. I can do the same thing with y. Y matches up with 12. So I can say, okay, that same ratio, 10 to 6, that I know has to hold for all sides, my other ratio then must be y over 12. Again, do a cross multiply. I get 6y equals 120. And I can divide 6, that's 20. And I got it. That's what the homework problems that you have are like. Okay, so give those a try. Hopefully this helps. And I'll just record another one for you tomorrow. Let me know if this one helped you or not. Okay, good luck. Just chat me if you have any questions. I'm here.